Now that you've got a basic idea about the NumPy library and also some idea about the NumPy array, uh, let's now move on to the next thing, which is NumPy array operations. So basically all types of arithmetic operations, like if you want to do addition, if you want to do subtraction, if you want to do product or division, everything can be done using the NumPy array. And it will be an element-wise addition or subtraction or product, right? So say, for example, if I just take two arrays having the different elements, it's a 2 by 3 array. Both of them are 2 by 3 arrays. And if I do a, say, for example, the element-wise addition, right? So what it does is simply, it does an element-wise addition, 32 plus 2, 34, 54 plus 2, 56. Like this, it goes on till the last element, which is 17 plus 5, 22, right? So that is being done. Same things apply for the subtraction or product or division or modulo, right? Now, there is one more very important concept in Python, which is the concept of vectorization. First of all, let's try to understand one very, important thing. In machine learning or deep learning, we do a lot of work with large volumes of data. I mean, we all know that as the volume of data increases, the models perform better and better. Now, with the increase in the number of data or the volume of data, the number of operations that need to be done for basic things like, say, looping and all, that increases drastically, right? And with the number of operations, the time complexity of the algorithm also increases. So one thing which can be done and which is being introduced using this vectorization concept is just replacing uh, these loops, right? So what happens is, say this is in case of a normal data set when we are doing the traditional operations like looping and all, right? If we want to apply a particular function on a particular, on the elements of an array, right? In that case, we have to do a loop and kind of apply the function on each of the elements of the array. But if you just get over that loop, if you can directly do something to apply the function on each of the elements of the array, then that will cut the cost of that loop, right? That is exactly being introduced in case of vectorization, right? That's why what happens is this, since this element-wise operation is being replaced, the time complexity is reduced by a few orders of magnitude, right? At least two or more orders of magnitude, it is reduced from. This is a big, what should I say, feature of Python as a programming language. Now let's try to see, instead of just talking about it theoretically, let's try to look at the actual code. So this is a code which we are going to execute in Google Colab. So what the code does is, in the initial portion of this code, it basically uses a traditional Python code where element by element, so there are two arrays which have been created, and the two arrays are quite large. We have used a list having three elements and multiplied it 10,000 times. So basically the array size is now 10,000 into 3, so 30,000. So two arrays of 30,000, size 30,000, they have been, we have to do a dot product of the elements of the array. So in a normal program, what we'll do, we'll have to do a for loop for each of the elements of the array, and then we have to do a product and then sum them up, right? So we will calculate that using the traditional programming way, and we'll also see how much time is it taking, right? We'll do the time analysis, and then we are going to use this vectorization concept and use this dot function, okay, dot, which will also do the dot product, and we will pass the two arrays having 30,000 elements each. And for that also we will see what value it is coming, okay, after the dot product, and what is the total time consumed by it, right? So we will run this code in Google Colab and let's see. So if you do that, you'll see that the values are both same. It is, I think, 3,20,000, the dot product value. But whereas the traditional programming using loop is taking 19.79 milliseconds, the program using vectorization concept takes only 0.14 milliseconds, which is like at least a order of 2 time gain, right? So this is the beauty of vectorization in the Python programming language, right? So we will see this thing. The other concept, which is also very important and used in Python, is the concept of broadcasting. Let's try to understand what is the meaning of broadcasting and how it is applied in Python. So what broadcasting does is basically it's a mechanism when there are two arrays where we are trying to do some kind of an arithmetic operation, like a simple addition or a simple subtraction. Say the two arrays don't have the same shape. What it does is uh, broadcasting, the concept of broadcasting replicates the array having the smaller dimensions. Okay, so what it does is, I mean, say for example, we have a array which is of dimension, say 3 cross 4, right? And then there is one more array which is of the dimension, say 2 cross 4. So what it will do is, when if we want to do a addition operation, what it will do is, since 3 cross 4 has 3 rows and 4 columns, 2 cross 4 has 2 rows and 4 columns, when we are trying to do addition of the third row from the first array, it will not have any corresponding row in the second array. What it will do is, it will replicate the first row again and it will add it, right? So there is a one important constraint to be followed if we want the broadcasting to work. What is that constraint? So basically, the larger array, I mean, whatever is the dimension, the smaller array, the trailing dimension needs to be the same. So for example, if we are talking about 2 cross 3 arrays, like here we were talking about 2 cross 3 arrays, right? Sorry, one 3 cross 4 array and one 2 cross 4 array. So basically we are talking about two-dimensional arrays. So the trailing dimension is basically the columns. So the number of columns rather, should be the same, right? Only then it is going to work, right? So here, say for example, we take the example of two arrays, 2 cross 3 and 3. 3 means there is only one row having 3 columns, right? If you want, I mean, if you try to add them up, so the first array is 32, 54, 2, and the second one is 75, 25, 17. And the second one is 2, 2, 4. That's it. Now, if we do an addition, what it will do is 32 plus 2, 34, 54 plus 2, 56, 2 plus 4, 6. Again, it will replicate these 2 to 4. So 73 plus 2, 75, 25 plus 2, 27, 17 plus 4, 21. So it will get replicated, right? So this is how it works, the concept of broadcasting. Now, in case they don't match, say for example, in this case, we have a 2 cross 3 array, right? The first one, the array var1 is a 2 cross 3 array. The second one, the array var2 is a 2 cross 2 array. It will simply give a value error, right? The shapes are not matching. It will immediately throw an error that the shapes 2 cross 3 and 2 cross 2, they are not matching and they are not ready for broadcast, right? Only if the second one has a dimension of 2 cross 3 or it has a dimension of 1 cross 3, then only it will be able to perform the broadcasting, otherwise not. Now, say in case the second one is a scalar, say second one is just a constant value 3, what will happen? It will simply replicate itself for as many number of elements are there in the array, right? So what will happen here is 32 plus 3, 37, 54, sorry, 35, 54 plus 3, 57, 2 plus 3, 5. Same ways, it will add 3 with each of the 3 elements in the second row also. So when we are trying to broadcast with the scalar gets replicated as many number of times as the number of elements in the larger array, right? This is how the concept of broadcasting works. So vectorization and broadcasting are two very important and critical features of Python programming, right? So now just a quick walkthrough of the different functions, and these are very self-explanatory. If you want to find the minimum value of the elements of an array, you can simply use the min function. Same way, if you want to find out the max value, you can use the max function. If you want to find out the cumulative sum, you can use the cum sum function. If you want to find out the mean, you can do that. If you want to find out the standard deviation, again, this is a very standard statistical function, you can do that. Now, you can just check it out if you want with one of the arrays which we had created. Say, for example, here the array object 4 was created with pre-filled values, right? So print object 4, this is there. And then if we just want to do a minimum, so how do we do that? Object dot min, right? So we simply do a obj 4 dot min. So what value should it return? It will return the minimum value. Let's see. So the minimum value is 12, it is returning a 12. Same way, we can do a max, right? If we do a max, it will return the 92, right? Because, sorry, this is a max. So it will return a 92. So like this, if you want to calculate the standard deviation, simply do a std and you run it. You'll get the standard deviation, which is 25.9. If you want to calculate the mean, simply do a mean and you'll get the mean value 44.1. So like this, you have the basic mathematical and statistical functions which are supported by NumPy, right? Like this, you have an array of other functions, or rather a bunch of other functions. The trigonometric functions, you have sine, cos, tan, all those things. You have the utility functions like around, floor. I mean, whenever we are looking at a floating point and you want to see the floor value, you want to get the ceiling value, all these things are provided as a part of the NumPy array library, right? Or the NumPy library. You have all these add, subtract as functions also. You can use the basic operators, plus or minus operators. You can also use the functions, add, subtract, multiply, divide. For power, raising to the power, you can use a power function, exponential, and all those things are there. All those utility functions are there as a part of NumPy library. Some more, like if you want to sort the values, you can do that, right? You can use where, you can find the index where a particular, or rather the index for a particular condition being satisfied, right? So all those utility functions, the mean and median statistical functions, mean already we have seen, you can also find the median. All those things are provided as a part of the NumPy library. So you can take more time and explore using Google Colab how to use each of these functions, right? So that is all about the NumPy library. And then we are going to come back with the next library, which is the pandas library, which is also very important library in terms of data manipulation. So till then, stay tuned. Thank you very much.